Okay, folks, so what we're going to look at here is try to figure out the oxidation states for each element in the formula. Now, the key here is to realize that any compound is going to be neutral. If we have a formula like a polyatomic that's got a charge, like say a phosphate or a sulfate, our oxidation numbers have to add up to whatever that charge is. So if we don't have a charge listed on any of these, we got to have our positive oxidation numbers and our negative oxidation numbers. They need to cancel out. So let's take a look at ammonia. So a couple of things that we saw in our notes is one of which was hydrogen always has a +1. So there's our +1. And in order to do that, in order to get this to balance out to 1, I'm sorry, to 0, since we have 3 hydrogens, our total positive oxidation number is +3. To balance a +3 out to get it down to 0, that means our nitrogen has to have a -3. Zinc oxide's done the same way. What we know for sure is that oxygen will always have a -2 oxidation number. And therefore, in order to get zinc oxide to cancel out their charge, not their charge, but their oxidation state, to get it to 0, that means our zinc has to be +2. Now notice for these first two examples, the oxidation number and the ionic charge is the same. A lot of times that'll be the case, but not all the time. So we can't necessarily say that one will always equal the other. Let's take a look for for water. By definition, hydrogen is always going to be a +1. Oxygen is always going to be a -2. And that makes sense because we've got 2 hydrogens in water, so 2 positive ones are going to cancel out the -2 from oxygen. Calcium hydroxide, all of these we know from our definitions. Calcium's in group 2, and according to the notes that we just took today, or yesterday, depending on when you're watching this, group 2 elements will have an oxidation state of +2. Oxygen will always have -2, and hydrogen will always have +1. So let's see how that works out. We have 2 hydrogens, that brings up to a +2, 2 oxygens, -4 is going to bring us down to -2. Now we're going to balance that out with our +2 from our calcium. Let's take a look at carbon dioxide. Well, we know oxygen, again, is a +2. Carbon, we don't have one of those definitions. We don't say carbon is always going to be a certain number. So we look to see what would bring 2 +2s. I'm sorry, I had +2. This is -2. What am I saying? So 2 -2s will bring us down to a -4. To balance that -4 out, that must mean that our carbon has a +4. Now, carbon, you might notice, is in group 14 on the periodic table. Elements in group 14, their charges as an ion could go either to +4 or -4. So, carbon, its oxidation number being +4, shouldn't be a huge surprise. Nitrogen, this is just an element, even though it's a diatomic element, those Hun 17 or Brinkelhoff or Hunkelbriffs. Anytime we just have an element, by definition, the oxidation state is 0. Sodium sulfate, I think we did this one in class, but let's try this again. Sodium is in group 1, so that's going to be a +1. Oxygen is always going to be a -2. So we have 2 positive ones, brings us a +2, and we have 4 -2s, that'll bring us a -8, but we know overall this whole thing has to equal 0. In order for a +2 and a -8, we add those together, we get a -6. To balance that -6 out, that sulfur has to be a +6. If we look at sulfur in the periodic table, +6 doesn't really go along with its charge. We know sulfur in group 16 always should have a -2 charge. That's why oxidation numbers and charges shouldn't necessarily be taken as the same thing, because they don't always behave that way. Aluminum hydroxide, oxygen, we said, is a -2. Hydrogen is a +1. So we have 3 -2s, so that brings us to a -6. We have 3 positive ones, so that's going to bring us up to a -3. To balance that -3 out, aluminum has to have a +3 charge. And then here we've got magnesium phosphate. So magnesium is in group 2, so it's got a +2. Oxygen, -2. So we've got 3 +2s, that's going to bring us up to a +6. We have 8 -2s, that's going to bring us up to a -16. So 6 plus a -16 is going to bring us up down to a -10. then that means these two phosphoruses have to balance a negative 10 out with a positive 10. So we're going to do that positive 10 divided by the two phosphoruses that are contributing to that positive 10, and that brings us to a positive 5. So that's how we figure out the oxidation states for the elements in these compounds. Now let's look at reactions to figure out what elements are oxidized and which ones are reduced. Real easy to do these things. I think I was kind of not getting things across really in class too well, and I apologize for that. Essentially, when we look at the ions from each side of the equation, if the ion's charge is increasing, it's going to be oxidizing. If it's going to be decreasing, it's going to be reduced. So here, this is just the element calcium, and by definition, calciums have oxidation states of 0. If we look over here, we know oxygen is a -2 oxidation state. To balance that out, we need a +2 for calcium. In order to go from calcium as a 0 charge to calcium as a +2 charge, we have to lose 2 electrons. So calcium lost electrons, its oxidation number increased from a 0 to a +2, so therefore we know that it's been oxidized. So calcium is oxidized. Then we've got our choice here. What are we going to look at here, the hydrogen or the oxygens? Well, oxygen, we said, is always going to be -2 unless it's by the element. So oxygen and oxygen staying the same. This is hydrogen, the element. So hydrogen is going to have a 0 oxidation state over here. But to balance that -2 out, we also know that hydrogen is going to have a +1. So we're going from H +1. Now we've got to add an electron to it to bring that oxidation state number down to 0. So we're reducing the charge or the oxidation number of hydrogen. So hydrogen has been reduced. Let's take a look at this next example here. These are both the elements, hydrogen and oxygen. So let's look at hydrogen individually. Hydrogen is going from neutral to having a +1 oxidation number. So we're increasing our oxidation number. So if we're increasing it, we are oxidized. So in this case, hydrogen is being oxidized. Here we're going from oxygen with a 0 as our oxidation number to oxygen in a compound. That's got a -2. In order to do that, we've got to gain 2 electrons. So let's say 2. So the charge, or not the charge, but the oxidation number is going from 0 to a -2. So that number has reduced. Therefore, it's the element that's being reduced. Let's look at the next couple examples here. So here we've got sodium plus iron 2 chloride yields sodium chloride and iron. If we notice, it's not balanced. We could balance these. That would really give us more correct. But we don't necessarily need to balance to figure out which element's oxidized or reduced. So here we've got the sodium element, an atom of sodium. So that's got an oxidation number of 0. But when it's in a compound, it's +1. So we're going from neutral sodium to a sodium ion by losing an electron. So our oxidation number has increased from a 0 to a +1. That corresponds to the element being oxidized. Now on this side here, iron is the ion. Iron is +2. Over here, iron is neutral. So to go from +2 to 0, we have to reduce our oxidation number. In order to do that, we have to add 2 electrons to it. Whoops. Put a 2, that's a -1 charge on that electron. You might say, well, Mr. Kane, we've got this chlorine. We didn't do anything with the chlorine. Well, if we look at the chlorine, chlorine here has got a -1 and a -1 oxidation number. So the chlorine was neither oxidized or reduced. Nothing really happened to it. Let's take a look at this one. This one kind of looks like a mess. And if you notice, there's some things missing from here. Actually, this isn't the one with the things missing from it. But so really all we have to do is look at our manganese, and look at our manganese over here. Here we're going from Mn with a +2 oxidation number to manganese. Let's figure out the oxidation state on this. Well, we know oxygen's a -2. There's 4 of them, so that brings us up to -8. Overall, I need my oxidation number to be -1. So what plus -8 will give you -1? And that's just going to be a +7. So to go from manganese +2 to a manganese +7, we need to remove a bunch of electrons. 5 of them. So our oxidation number has increased, so that means we're going to be oxidized. Let's take a look at our SB. So in this case, SB, well, 4 times 2 is going to give us 8 for the oxygens. We need an overall oxidation number of -1, so this is going to be SB plus 7 over here. And then we're going to end up with SB plus 3. We do that by adding 4 electrons to our plus 7 ion. Our oxidation number went from a plus 7 to a plus 3, therefore it reduced by 4, and that's our element that's being reduced. All right, let's take a look at this example here. We got the dichromate ion combining with the tin ion to make a chromate, or a chromium ion, a chromium 3 ion, and a tin positive 4 ion. So here we've got, let's take a look at our chromium. Let's find our oxidation number for that. Well, 7 times -2 gives you -14 for our oxygen. What plus the -14 will give us a -2? Well, that's -12. We're going to divide that by our 2 to give us an oxidation number of -6. To become, I'm sorry, that's +6. This chromate, or chromium ion, its oxidation number is going from a 6 to a 3. So its oxidation number is reducing, and we do that by adding 3 electrons to it. Let's take a look at what's happening to our tin. So we're going from a tin plus 2 to a tin plus 4. The way we do that is we lose 2 electrons. So our oxidation number is increased. Therefore, tin is being oxidized. Let's take a look at number 4. Here we've got silver. This really should be, these should be aqueous. It's not going to affect how we do this, but it just bothers me. So there we're going from silver, it's the metal, so it's got an oxidation number of 0. We're going to silver plus 1 ion. The way we do that is by removing an electron from our neutral, from our metal. So a positive ion of silver plus an electron will bring us down to a silver atom. So we're going from a 0 to a plus 1. We're increasing our oxidation number. That means we're going to be oxidized, and that's going to give us silver. Now oxygen, it's going to be -2 in both of them, so really let's take a look at what's happening to our nitrogens here. Here, on the left-hand side of our equation, well, we've got 3 -2s, that'll give us a -6, and we need to have something to add up to a -1. So what plus -6 will give you -1? Well, that's going to be 5. So nitrogen with a plus 5 oxidation number, it's going to turn into nitrogen. Well, this is neutral, so that's a -2, and that's got to be a +2 to a nitrogen +2. The way we do that is we have to add 3 electrons to it. So here we're reducing our oxidation number from a 5 to a 2. Nitrogen's being reduced. So here we've got a copper +2, and then we've got a copper, just the plain old element. So we're going copper +2 plus 2 electrons yields copper with a charge of 0. So we're going from a +2 to a 0. We're reducing our oxidation number. So copper is being reduced. Let's take a look at our cerium. So we're going from a Ce with a +3 charge. Now remember, our oxygens are -2, and there's 2 of them, so that makes that -4. To balance that out, because this whole thing is neutral, we've got to have a +4 on our cerium. In order to do that, we have to lose an electron. So cerium +3 is going to give up an electron to become cerium +4. So our oxidation number is increased, and that's going to give us cerium being our oxidized compound. So I have about 30 seconds left. I can try to do this one in the time allotted, but I doubt I'll be able to do that. So I'm just going to kind of solve this with this video paused, and then hit record again and see if you come up with the same answer as I did. I find that phosphorus went from the element of phosphorus to a phosphorus with an oxidation number of 5, so it's increased our oxidation number, so that makes phosphorus the oxidized one. We went from copper ions to copper metal by decreasing our oxidation number, So that's our reduced